In this lesson, we're going to discuss properties of logarithms. All right, so we've learned a couple properties already. These are just some more that might help you in certain problems. This first one is a change of base, and that's just when you have a log with a base of something, you can change it to be a ratio of two different logs, right, with a completely different base. So the ratio is log with a base of the big number over log with a base of the little number, right? So you notice that there's an ln here and just a log with a base of b, right? But no matter what, it's this big number inside on top and then the little number on the bottom, right? This is especially useful if you want to calculate something like log base 3 of 23, right? Here's just an example on this page. Your calculator, especially if it's just a scientific calculator, right? Graphing calculators have the option to put in a base, but most scientific calculators just have a log button or they just have an ln button, right? Or, well, they'll have both, right? But it'll be just log and just ln, not an option to put log with a base of something, right? So this helps you get some sort of approximation when you can't find an exact answer, right? So for example, 3, I can't raise 3 to an exact number, or exact like whole number, integer, or anything to get 23 as an answer, right? It's going to be like a strange decimal, right? So we can use change of base and say that this is the same as log of 23 over log of 3. And that's the same as ln of 23 over ln of 3. Just one thing that you cannot do is, let's say you do log of 23 on top and then ln of 3 on the bottom, right? That's no longer the property, right? The property is that they need to have the same base on the top and the bottom, right? So that can't work. It just needs to be one or the other, right? Log of 23 over log of 3 or ln of 23 over ln of 3, all right? And those are going to be exactly the same as if you were to just do log base 3 of 23. All right, so let's just do some examples. It's actually super easy, right? You're going to see that log base 4 of 25, we can rewrite very easily as a ratio of common or natural logs, right? The common log, we just call the regular log with the base of 10. And then natural log, we call the log with the base of e. So ln or just regular log, all right? And this log base 4 of 25, it's going to be log of the big number over log of the little number. So I have log of 25 over log of 4, or this is ln of 25 over ln of 4, all right? And then you can approximate this to 4 decimal places, and it's approximately 3219. All right, so that's to 4 decimal places. We can do the exact same thing with the next one. We can say that this is log of 12 over log of 2, or we can say that this is ln of 12 over ln of 2, and then once again, this is much easier to plug into your calculator, right? So you can plug this in, and you're going to get, all right, when you do, let's try ln, right? ln of 12 over ln of 2, that's going to get you approximately 3.5850, right? It rounds up, so there's a little 0 at the end, but that's still 4 decimal places. All right, but that's it for that property, right? Doesn't really get any crazier than that. All right, so these are the new stuff also, right? So we have a power, a quotient, and a power property of logs. These go hands in hand with the power, product, and quotient properties of exponents, right? So you know that if you multiply with the same base, you add, divide with the same base, you subtract, and power to a power, you multiply the powers, right? So you guys already know that kind of stuff. We have the exact same thing with logarithms, right? So if I have log base a of u times v, that's the same as log base a of u plus log base a of v, all right? And if with multiplication you add, I'm sure you can guess with division you would subtract, right? If I have log base a of u divided by v, that's log base a of u minus log base a of v, all right? And then you have a power property where if I have log base a of u to the power of n, that n can move out front, and it's n times log base a of u, all right? And you're going to see that some problems we're just going to ask you to expand it, as in make it as big as you can, right? No more multiplication, division, or exponents inside of your logs. Or we'll ask you to condense it. So meaning if you see multiple logs in a single problem, make it so that you only see one log, right? And you're not really going to see the purpose in this particular lesson, but you are going to see the purpose in our next lesson where we start solving log equations. All right? So let's first start with something that we've already done before, right? I have log base 5 of the cube root of 5 equals x, right? Keep in mind, this is the same as log base 5 of 5 to the 1/3. And you guys know that we can cross out the log base 5 and the 5, and then we just get x equals 1/3, right? But the reason that works is if you were to use one of our power properties that we learned in the previous slide, that exponent can move out front, and this becomes 1/3 times log base 5 of 5. And we know that log base anything of itself is going to get you 1. So this is the same as 1/3 times 1, which gets us our final answer of 1/3. All right? You don't have to show that much work, right? A lot of times you can just tell right away what the answer is going to be, as like you can just cross out the base, and then you're just left with the exponent, right? That's perfectly fine. I'm just showing you another way to look at it, right? And that's why we get the answer that we get. All right? The rest of the examples on this page are going to ask you to expand or condense, right? Well, in this page, we just ask you to expand, right? So meaning write as many logs as you can in a single problem. And so what you're going to do is you're going to look inside of your log, and you're going to ask, is there any multiplication, division, or exponents in this problem? In this particular problem, we have a multiplication of 5 times x to the third, and then I have another multiplication with an x to the third times y. So I know for sure that has to become a plus, and that also has to become a plus. All right? Another thing that I see is an exponent, and I know that the exponents are going to move to the front of that log. All right? I don't see any other multiplication, division, or exponents in this problem, so that means I know in my final answer, I know I definitely need 2 pluses and a number in front. All right? When I'm expanding, I like to do the multiplication division first from left to right. So I'm going to do it one step at a time, right? I'm going to show you that this is going to become log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y, right? And those are our 2 pluses, right? So that accounts for that, check and check, right? The last thing we know for sure that we need in our final answer is a number in front, right? And notice that the exponent is over this x, so it's going to go in front of this log, right? Just this one. This is the only one that has the exponent. So that means my final answer is going to be log with a base of 4 of 5 plus 3 times log base 4 of x plus a log base 4 of y, right? And that's checked on the front, right? So that's our final answer. This is fully expanded. I don't see any other multiplication, division, or exponents in my logarithm, so I know we're done, right? Let's try the exact same thing with the next one, right? Notice that I see a division, right? I see that something is being divided, and that's going to tell you that in your final answer, that's going to become a subtraction, all right? And another thing that I see is a square root. You're probably like, okay, what does the square root mean, right? Hopefully you remember that this is going to become, right, everything raised to the 1/2, right? So I know that the 1/2 is going to have to go in the front with our property of exponents, and then that division is going to have to turn into a minus, right? I don't see any other division or multiplication or exponents in this problem, so I know in my final answer I'm going to need 1 subtraction and a number in front, right? Once again, I would go one at a time. I would do the multiplication division first from left to right. I would take the entire thing on top which is ln of 3x minus 5 to the 1/2 minus the entire thing on the bottom, ln of 7. All right, so that accounts for the minus, check, right? And then I have a 1/2 in the exponent that I want to move to the front. And then so this is going to become 1/2 ln of 3x minus 5 minus ln of 7, right? And that accounts for the exponent in front, right? Check. And then that's it for this one. That's all we have to do there. All right. Let's try the same thing with the next one, right? I see a couple things here. I see a multiplication. I see 4 times x squared. That's going to become a plus. And then I also see a division. That's going to become a subtraction. And then I see the square root of y, and that's going to become to the power of 1/2, right? So I know in my final answer, I'm going to need a plus, I'm going to need a minus, and I'm going to need a 1/2 in front. Again, I would do whatever's happening to the whole thing first. So from left to right, you probably would do the multiplication, but I would make sure that I have this entire thing on top clearly being subtracted from the entire thing on the bottom. So I'm going to do log base 3 of 4x squared minus log base 3 of y to the 1/2. All right. And that accounts for the minus, right? Check. All right, I actually forgot one, right? There's an exponent of 2 here. That's another thing that's going to move to the front with the 1/2, right? So I checked off the minus. Let's account for the plus now, right? I see a multiplication in between. So that means I'm going to turn this into a log base 3 of 4 plus log base 3 of x squared minus log base 3 of y to the 1/2. All right, and that accounts for the plus, check. All right, and then I want to move these two numbers out front. So I'm going to move the 2 out front and the 1/2 out front, and that's going to give us log base 3 of 4 plus 2 log base 3 of x minus 1/2 log base 3 of y. All right, and then that is my final answer. There's nothing else that I can do, so check and check. All right, we already did all of our exponents. So this is fully expanded. All right. And now we're going to go in the opposite direction. We're going to condense, right? So when you condense, you want to write it as a singular log, right? You see multiple per problem. You just want to write it as one single log. So now we're going to work backwards, right? We're going to see what do we have in front, what pluses and minuses do we have in between, right? And in this particular problem, I see a 1/2 in front. I know that's going to become an exponent. I see a 3 in front. I know that's going to become an exponent. And then I see a plus in between. I know that's going to be a multiplication. So that means in my final logarithm, I'm going to need 2 exponents and I'm going to need something being multiplied. All right, so let's work backwards. So this time I'm actually going to take care of the exponents first, and I'm going to move those on top of whatever's on the inside. So I know that this is going to be a log of x to the 1/2, but I know that anything to the 1/2 is the same as a square root. So I have log square root of x plus log x plus 1 to the power of 3. All right, and that takes care of those exponents, right? Let me check those. And then the last thing I see is a plus in between. That means I'm going to multiply on the inside. So this is going to become log square root of x times x plus 1 to the 3rd power. Right? And now this is one singular log. I don't see anything else that I can do to this, so this is fully condensed. All right? It shouldn't be too bad, right? So let's try the same thing with the next one. I see a 2 in front. I know that that's going to become an exponent. And then I see a minus in between. That's going to become division. Right? So let's do our properties of logs to condense it. And again, I'm going to work backwards, so I'm going to do the exponents first. So this is going to become ln of x plus 2 squared minus ln of x. And then once again, I see a minus. I know that I'm going to have to divide now. So this is going to become ln of x plus 2 squared over x, right? And that's fully condensed. There's nothing more I can do to that, right? We checked the exponent and we checked the division. All right, so hopefully not too bad. All right, let's try this next one. This next one, notice now I have a group around two different logs and then something else happening on the outside. All right, so let's, just like with our order of operations, let's work on the inside first. On the inside, I see a plus. I know that that has to be a multiplication. So that means I'm going to multiply the x with the x plus 1. This is going to become a log base 2 of x times x plus 1. And that checks off the plus. And then I see a 1/3 over the whole thing. So let me just write that down here. And I know that that is going to become an exponent over this whole thing on the inside, right? So that's going to become log base 2 of, if you want, we can simplify this, right? On the inside, I can just do x times x plus 1. And that's going to get us x squared plus x to the 1/3. And also notice anything to the 1/3 we can write as a cube root, right? So we, at this point, we did condense it. I'm just going to write it as a cube root instead, right? So this is going to be the cube root of x squared plus x. And that is fully condensed, right? Nothing more we can do to that. We have a singular log. All right, so let's try the same exact thing with this last one, right? Again, work on the inside and then look out. I have a minus that's going to become a division. And then I see a 2 that's going to become an exponent, right? So let me work with the exponent first. This is going to become a log of x plus 3 minus log of x minus 2 squared. All right, and then I still see that minus in between. That's going to become a division. So this is going to become log of x plus 3 over x minus 2 squared. And then I still have that 2 on the outside. So this whole thing is going to need an exponent of 2. All right, so this is going to become log of, I'm going to square the top and then square the bottom. So this is going to become log of x plus 3 squared over x minus 2 squared is going to get us an x minus 2 to the 4th. And then that is our final answer, fully condensed. That accounts for everything. So hopefully you're seeing it's not too bad, right? You just have to be careful and make sure that you're accounting for every single plus, minus, exponent, that sort of thing. All right. And again, you're going to see in the next lesson that these are going to help us solve all kinds of log equations, right? Sometimes in certain problems, you're going to see a couple different logs in a single equation, and the condensing just makes it a lot easier to solve and match things up, right? And you're going to see in the next lesson, right? But this is just a quiz. I'm sorry, not a quiz. This is just a lesson on the different kinds of properties of logs, right? All the remaining ones that we had to talk about, all right?